Good day, science explorers, Sir Cedric here. Today we will talk about the periodic table. In this journey, we will walk through early days of the periodic table, people behind the development of the periodic table, and its current state. The periodic table is a tabular display of all known chemical elements. It is the single most important tool in chemistry. It organizes elements by their properties, allowing scientists to predict how they will behave and react with one another. Let's walk through its early days. In the early 1800s, chemistry was a mess. Scientists knew about elements, but they had no way to organize them. It was like a library with no shelves. That is, until four brilliant minds changed everything. First up, Johann Dobereiner. In 1817, he noticed that elements often came in groups of three with similar properties. He called these triads. He even realized the middle element's weight was the average of the other two. It was the first hint that elements were related. By 1864, John Newlands took it further. He arranged elements by atomic mass and noticed a pattern. Every eighth element behaved similarly. He called this the law of octaves, just like music. People laughed at him at the time, but he was onto something: periodicity. Then came the big one, Dmitry Mendeleev in 1869. He also used atomic mass, but he did something genius: he left gaps. He predicted that elements existed that hadn't been found yet, like gallium. When they were discovered later and fit his gaps perfectly, the world realized he was a legend. But there was one tiny problem. A few elements didn't fit the mass pattern. In 1913, Henry Moseley used X-rays to discover the atomic number, the number of protons. He rearranged the table by atomic number instead of mass, and suddenly, every single element fell perfectly into place. Now let's go to the structure of the periodic table. Elements on the periodic table is categorized into three major groups: metal, non-metal, and metalloid. Metals are shiny, malleable, meaning it can be shaped, and good conductors. And located on the leftmost side. Non-metals are dull, brittle, meaning it is easily got shattered, and poor conductors. And located on the rightmost side. Metalloids have properties of both. Found along the staircase area on the right side. Period and group. Group is the vertical columns 1 to 18. Elements in a group that share similar chemical properties and valence electrons are number of electrons on their outer shell. Period is the horizontal rows 1 to 7. Elements in a row have the same number of electron shells. Group and period are also a good way in locating the element on the periodic table, precisely like a coordinate system. Now, let's go the last part, the groups or families. Group 1. Alkali metal family. These are the most reactive metals in the table. Soft enough to cut with a knife, react violently with water. And produces hydrogen when reacting with water. Lithium, sodium, potassium are included to this family. Group 2. Alkaline metal family. They are harder and denser than Group 1 metals. Very reactive, but less than the alkali metals. Includes calcium in bones and magnesium in chlorophyll. Groups 3 to 12. Transition metal family. These are the classic metals we use in everyday life, like iron, copper, silver, and gold. These elements are very strong and durable, high melting points, often form colorful compounds. Group 17. The halogen family. The salt formers. These are the most reactive nonmetals. Toxic and highly reactive, exist as solids, liquids, and gases, often used as disinfectants like chlorine and iodine. Group 18. Noble gases family. The socially distanced elements. They are extremely unreactive nonmetals. Noble gases have a full outer shell of electrons. This makes them very stable and unreactive. They are all colorless gases at room temperature and have very low boiling points. Includes helium, neon, and argon. And there you have it. A brief walk through the periodic table. See you next time.
Since you reached this far, if you enjoy this video, hit that like button and share this to your friends. As Sir Cedric always says, learning is forever. See you next time. Bye.